Okay, activity series. The activity series of metals lists the metals in order of decreasing tendency to lose electrons. So the ones at the top of the list are the most likely to lose electrons. They are the most easily oxidized. That makes them the most reactive. The ones at the bottom have the least tendency to lose electrons. They are the least reactive. So here's the activity series, and you do not have to memorize this. What they do is they list half reactions. So here, a lithium atom losing an electron. Lithium is the most active metal, and so it's at the top of the list. Gold, of these elements listed here, gold is the least reactive metal, the least likely to lose electrons and form an ion. And so there's this list. It's an order of priority. And then we have hydrogen in the middle because, you know, hydrogen has to be an exception to everything. It's a non-metal, but it has to be in here because hydrogen also has a tendency to lose electrons. So half reactions at the top are likely to go in the forward direction. Half reactions at the bottom are more likely to go in the reverse direction. And you can predict whether a reaction will be spontaneous by seeing which half reaction is on top. So if you have one of these half reactions paired with the reverse of a reaction below it, then it will happen spontaneously. So gold, there's a reason that people make jewelry and things out of gold, not just because it's pretty. It's very unreactive. Gold doesn't tarnish. I have a gold wedding ring. I never have to worry about it tarnishing. But if you have silver, silver tarnishes. Silver is a little more active. You definitely wouldn't want to make fine jewelry out of like lithium or something because it'll react with the moisture in your skin and it'll just not last at all. Gold and silver and platinum don't make compounds very easily, and that also makes them very useful. So that's all nice, but this is what we need to know how to do. Determining whether each of these reactions is going to be spontaneous or not. I feel like there's something missing. Yeah, I missed this picture. Okay, yeah, this was like the introduction to the whole thing. We'll just jump back here. If we take a strip of magnesium and stick it in a solution of copper ions, a reaction occurs. The magnesium begins to dissolve and copper deposits on the magnesium. Like, okay, well, that's kind of interesting. If we do the opposite, if we take a copper strip and put it in a magnesium solution, nothing happens. So this reaction can go in the forward direction. It can be forced to go in the reverse reaction, but it's not going to happen spontaneously. The activity series is what helps us to predict what's going to happen. No, this is kind of tiny, but if we were to put some spectator ions back in here, maybe made this copper chloride, and then this would end up being magnesium chloride. What kind of a chemical reaction is that? Is it double replacement or neutralization or? Here we have a guy, the metals are guys, right? Metals are male. And here we have a guy with a girl, and they're going to a party, right? And magnesium leaves with the girl and copper leaves by himself. This is a single displacement or single replacement reaction. Why did magnesium get the girl? Why didn't copper keep her? Because magnesium was cooler, right? He's more macho. So magnesium is just this chick magnet, right? He gets the girls. He's cooler than copper. Copper brought a girl to the party. Copper can get girls, but not when magnesium's around. Magnesium's going to steal the girls. So this list, this is the list of which guys are the coolest. So lithium, he's like, you know, the top of the list. He's the one everybody wants to go home from the party with. Here's magnesium, and down here's copper. So magnesium is higher on the list. It's no wonder. Magnesium gets the girl. So magnesium is going to get the ions, and copper's going to be left going home by himself. That's how I think of the activity series. So then when we do a problem like this, here we have zinc and nickel. Now it's not showing the spectator ions, but because this is an ion, that means that he came in with somebody. So nickel came in with the girl, and zinc's leaving with the girl. Well, is that going to happen? We have to go over to the list of guys and see who's cooler, zinc or nickel. Well, here's nickel, and there's zinc. Who's more active? Zinc is more active. So zinc is going to take nickel's girl. Zinc is going to leave as the ion. You like that? I know, it's dumb, but it works. So is this reaction spontaneous? Yeah. What if we tried to run the reaction backwards and nickel came to the dance or the party by himself and zinc had the girl? Would zinc give the girl up to nickel? No, because he's more macho. He's stronger, he's more attractive, whatever you want to think about it. So this one is spontaneous. And then we're also asked to look at zinc and calcium. And again, you're looking at who is higher on the list. So who's more macho, zinc or calcium? Calcium. So is calcium, who brought the girl, zinc or calcium? Calcium did. This is his positive charge with the girl, right? Calcium brought the girls. Whoops. Is calcium going to let zinc take him away? No. So this reaction is not going to happen. So we say it's not spontaneous. Any questions? The chemical world is a little more easy to predict than the dating scene, right? No questions? Well, we mentioned earlier that many metals will dissolve in acids, but not all of them will. And the way we can predict whether that happens is by, again, looking at the activity series. Remember, hydrogen was on the activity series. Hydrogen's a little guy, but he's cooler than some of those metals. He's more macho, more active. So metals that are above hydrogen on the activity series, I'm having a brain fart. Metals above hydrogen dissolve. Metals below do not. Yeah, this is suddenly just not making sense to me. So we've got zinc and hydrogen. Zinc is, sorry, zinc, here's zinc. Zinc is above hydrogen. Okay, so does my rule of who's cooler work with this? No, it doesn't. Because hydrogen has to be an exception to everything. Okay, so we're looking at hydrogen and it's backwards. So a question like this, will silver dissolve in hydrobromic acid? No. Silver is below hydrogen, so no, it will not. Most metals will dissolve in hydrogen, but these guys will not. Yes?
That's true for all acids?
This is a generalization.
Okay.
You can dissolve copper, silver, and gold in acid, but it has to be a certain kind of acid, and it works by a different redox reaction than the H2 to H+. Yeah.